3-5 complex numbers, what we're going to focus on today is to perform different operations with complex numbers. So that's going to be addition, subtraction, division. And then something you might remember from last year is that complex numbers have the form a plus bi, and that is the form that you're going to want to write your answers in when we perform operations. And then I squared is going to be -1. Remember, that comes from I is the square root of -1. How many of you do remember this from last year, the imaginary? Okay, so I'll try to cut down my explanation time if it's something that we're familiar with. Sound good? Okay, so for example 1, we are going to find the real and imaginary parts of each complex number. So if you have 4 plus 9i, okay, it's going to be as simple as saying this is the real part, this is the imaginary part. So in a plus bi, this is the real part, so it would be 4. The imaginary part would be 9. Don't put the I with it, it's only the coefficient. Okay? Now, if you get 1, that's -6 minus 7i over 2. If this was something that we had, we would split it up. So we do have to simplify it first. So when you simplify, it would be -6 over 2 minus 7 over 2i. So -3 minus 7 over 2i. And then you would just identify the real part, which is -3, and the imaginary part, which is -7 over 2. Okay, and you will have some questions that are just like that, so those should go pretty quickly. Alright, so for example 2, we're going to evaluate the expression, and then again you're going to write the result in this form. So there is addition. When you're adding, you're just going to combine your like terms.
So for all of these ones that we're about to do, we have to do what we just did?
You're just going to show like this step, yeah, just like that.
We have to do real and imaginary.
Yes, just the real, just for those. Okay, so now we're going to move on to the operations. So when you have subtraction, I'm going to try to lock it. Just hold on a sec. Okay, so when you have the 6 minus the 5i, I'm going to read it to you. So it's 6 minus 5i in parentheses, and then minus, and then another set of parentheses, and then in the parentheses 2 plus 3i. Okay, so in the second set of parentheses, 2 plus 3i. Okay, so then this is again something that you would have done in Algebra 2. So good, I can see some of you are already doing it. Yeah, you just make sure that you distribute the negative. That's the main thing there, okay? So -2 minus 3i, combine your like terms, 6 minus 2 is 4, -5i minus 3i, -8i, and then it's in its proper form, okay? If you were adding, it would be, you would just add the like terms together, okay? All right, and then for B, so we're moving on from that. Now we're going to do FOIL. So 6 minus 5i times 2 plus 3i. Okay, so when you FOIL, you're doing first, outer, inner, last, or if you're like me, I like to FEIL. So 6 times 2 is 12. And then I like to do the center like this, so I have negative 10i here, and then 6 times 3i would be 18i, so that would make plus 8i. I like to do that because I know that those are going to be my terms that I'm adding together. And then when I do the last term times the last term, negative 5 times 3 is negative 15. When you multiply I by I, you get I squared. Now, earlier we mentioned that I squared is equal to what? Yep, so anytime you get I squared, you do have to make sure that you substitute negative 1 in. So if you substitute that in, then you have 12 plus 8i plus 15. A negative times a negative is a positive, and then you can combine your like terms. Again, we're writing that in a plus bi form. Okay? Okay. For C, we're going to move on to this. Do you guys remember your first step for simplifying? If you have I to a power, you have to rewrite it with I squared. Okay, so you rewrite with I squared. And what you have to do is you have to use your knowledge of powers. So by that, what I mean is, if you have I squared, and you want to rewrite it as a power to a power, okay, we're going to use a power to a power rule. The power to a power, you multiply them together. So when you're rewriting it, you should still have I to the 18th power, it's just in a different form. Do you guys know what it is? Yeah, what is it? 9. Yep, I squared to the 9th, because 2 times 9 is 18. So all you have to do is divide it by 2. Okay? So now we're just going to plug in negative 1, and then negative 1 to the 9th power, is that a positive 1 or a negative 1? Negative. Okay? And then what type of power would you have in order for it to be positive 1? Yep, good. So if it's odd, it'll be negative. If it's even, it's not. Okay, well that one was an even power to start with. What if we had an odd power to start with? Do you guys remember how we do that? Yep. So how many times does 2 go into 33 without going over? 16. And then how many would be left over? An I. Okay, so now you're using your power to a power and the product rule. Because 2 times 16 is 32, right? And remember, if you had I to the 32nd times I, what would you do with those exponents? You'd add them. And see how it would be the same thing? It's still I to the 33. So that's what we're doing here. Do you guys want me to say that one more time? Okay, so you're taking half. How many times does 2 go in there? And then if this is an even number, this is odd, just multiply by the I. Okay, so then we're just going to do negative 1 to the 16th times I. Negative 1 to the 16th is positive 1. 1 times I is just going to be I. So if there's no coefficient on these, your answer would either be negative 1, positive 1, negative I, positive I. If there is a coefficient, you'll be doing some multiplying. Okay? All right, any questions for me on that? I'll give this to you when we're done, okay? All right, let's do division? Sure. Now, when we're doing division, okay, when we're doing division, you don't want I in the denominator in the simplest form. Okay? The reason why you don't want I in the denominator is something that you've been told for a long time, and it's not in simplest form if there's a radical in the denominator. Remember, I is the square root of negative 1. Okay, so you do not want I in the denominator because it equals negative 1. No? no radicals. We don't want those in the denominator. It's just not the simplest form. Okay, that's why we rationalize. What's that? Yeah, good. Nice use of vocab. So we're going to multiply by the what, Grayson? Conjugate. Okay. So this is the complex conjugate. Okay. Do you guys remember what this? Caleb? So it'll be the opposite. So it'll be what? For this one, what will it be? Yeah. If it's a plus bi, it's a minus bi. Yep. 1 plus 3i. Great. All right, so now we're going to FOIL on the top and we're going to FOIL on the bottom. Now, I've been doing this with my Algebra 2 students, and what I've noticed is what people tend to mess up on is they see the 3 and the 3, and they'll write a 3, or sometimes they'll write plus instead of minus. But remember, 1 times 1 is 1, 3i times negative 3i is negative 9i squared. And that should happen. The middle terms should cancel out. You should get 3i and negative 3i. It should be 0. And that's why you're just left with the 1 times 1 on the negative 3i times the negative 3i. Now, we just talked about if there's an I squared, you have to plug in negative 1. So really, the bottom becomes 1 plus 9. If you multiply by the conjugate, this should always turn into a plus. Okay? Now, on the top, we're going to have to FOIL. 5 times 1, 5. I like to do the inside first, so if you like to do the outside, it's okay. It's going to simplify the same. And then 18i squared. So, like terms, we combine together. And then if I plug in negative 1, this becomes a minus 18. Okay, so you're going to do 5 minus 18, and then 6i plus 15, so 21. 5 minus 18 is going to be negative 13, and then one more step, and that's to write it in a plus bi form. Okay, and then if you can't reduce the fraction, leave it. So negative 13 over 10, plus in the middle, because this is positive, and then 21 over 10i. That is a plus bi form. Okay? All right, and then F. There are many different ways that you can do F. So there are different things you can multiply. So I want you to think about that, and then